Hi everyone, it's Katie here from TeamSQL, and I want to welcome you to Introduction to SQL using TeamSQL. This is a crash course in SQL. But before we get started, I'd like to introduce myself. I'm a software engineer turned content creator, and I've been working with SQL, specifically TSQL, for about 6 years now. I've since dabbled a bit with Redshift, MySQL, and Redis. Today I spent a lot of time writing about SQL, including how-to guides, tutorials, best practice docs, and so on. Anyway, as I said, this is a crash course in SQL. By the time you finish this course, you should be able to return and view data, create complex queries, and manage your data tables. You'll also be able to use some special TeamSQL features designed to make it easier to work with your data. While we'll be working exclusively in TeamSQL, a data management client that works across multiple platforms and interfaces with many different types of database environments, the SQL concepts in this course are generally applicable no matter where you're working. If you don't already have a copy of TeamSQL, you can download it and try it out for free. We'll put the link to get this trial in the course notes. Let's talk a bit more about this course. While we assume that you have some exposure to programming, we'll assume that you're a novice when it comes to SQL. We'll begin by talking about SQL, what it is, and how it's useful. We'll also cover relational databases, just in case you haven't encountered that term before. Our course will then be divided into 5 parts. Most of our work will be in the Redshift environment, but if this isn't something available to you, the queries that we write can easily be generalized to other database environments. First, we will cover how to write and execute simple queries against just one table. Then, we will cover joins so that you can execute queries against multiple tables. This will lead us into complex queries, where we'll talk about writing subqueries, using set operations, and aggregate functions. Of course, you won't always be working against pre-existing tables, so we'll spend time on managing data. We'll cover how to work with tables and best practices for creating, updating, and deleting data and tables. Finally, we will talk about special TeamSQL features that make it easier for you to work with SQL databases. These are also features that we think will help you learn to write SQL. Additionally, we'll cover the collaboration and sharing tools included. It's more likely than not that someday you'll need to share your queries, data, or a specific result set with a colleague, so we'll talk about the different ways that you can do so in TeamSQL. With all that said, let's get started. So first let's talk about what SQL is. SQL stands for Structured Query Language, which is a programming language developed in the 1970s. You'll most commonly see it used for communicating with relational databases to do things like return data or manage tables that you use to store data. There are several variants on the basic SQL language, mostly in terms of how you structure complex syntax, but the overall concepts are the same from system to system. So relational databases. Obviously, a database is a place where you can store and organize your data, but what makes something a relational database instead of a just plain old database? Well, when someone calls a database relational, they mean that the database follows what are called the rules of normalization. Simply speaking, this means that we divide our information into multiple tables so that we have a place for everything and everything is in its place. The goal is to have each piece of information appearing only once, and using the appropriate identifiers, which we'll cover in a later video, we can cross-reference our tables. So let's look at a very simple example. Suppose we have a table for users with their names. We also have a table listing the user's favorite books. In the latter table, the user might have more than one favorite book, which means they get multiple lines. However, rather than including every detail about the person on every line in the books table, which could lead to a lot of redundancy, we'll identify the user with an ID number. Then we can find all of the user's favorite books by querying based on this ID. If we want the identifying information about the user, we use the ID to cross-check the user's table. So that's a very brief, high-level description on what SQL is and what a relational database is. In our next video, we will begin our crash course in SQL using TeamSQL to interact with our Redshift database. Go ahead and fire up your instance of Redshift and tune in for our next video, SQL Basics Part 1. This quick start video will get you up and running with TeamSQL in no time. When you launch the software for the first time, you'll have to sign up for an account to use TeamSQL. If you already have an account, you can go ahead and sign in with your email address and password. Once you've signed in, the first thing you'll want to do is create a connection to your server. To create a new connection to your server, click on the plus button. Select your database type and provide the requested information. When done, test connection. If your credentials work, click Save so that you do not have to re-enter your connection information the next time you use TeamSQL. While you have to connect to each of your servers individually, you can connect to multiple servers using TeamSQL. This means that you can use TeamSQL to manage all of your server instances regardless of whether you're running a MySQL database, SQL Server database, or AWS Redshift. To connect to your server, click on the socket icon next to your server name. Once TeamSQL has successfully connected, you'll see a green dot indicating such. At this point, you're ready to run your first query. To do so, you'll need to open up a query execution window. You can do so by going to File, New Query, or you can hit Control or Command N. Alternatively, you can right-click on the table name and click the Open Table option to look at the first 200 results returned. Now that you've returned a subset of data from your table, you can manipulate the data or share it as you need. All of the shared data functions can be accessed by right-clicking anywhere on the data table. You can copy as little as a single cell or as much as the entire table. You have the option of copying the data as JSON, CSV, or tab-separated data. Alternatively, you can also export the data to those exact same file formats. One additional feature that TeamSQL offers is the ability to share as URL. What this means is that you will create a custom URL that you can share to your colleagues. Your colleagues, by navigating to that URL, can see the entire result set. If you make any changes to the query you're executing, you can rerun the query by clicking the Execute button. You can save your query for future reference by using the Save button in the top right or by using Command or Control S. You can also easily collaborate on this query by using the Share button in the top right. You can share the query itself, or you can share the results as link. If you ever want to refer to any of the queries you've executed, you can do so using the History tab. Opening it up, you can search for queries using the filter, or you can scroll down to find the query you're interested in. If you click on any of the queries that appear in your History tab, it will execute. You will be able to see the full query that was executed as well as the result set. If you right-click on the result set, you will get the same sharing options as you would if you had used the main query editor window. You can also manage the queries you've saved using the Saved Queries area. You can see that there's a list of your files as well as the files that have been shared with you. If you are a part of one or more teams, you'll see the team listing in the left-hand side as well. You will also see the connections that you have made. The Saved Queries area is also where you manage the sharing of queries with individuals and your team members. By clicking on a query, you'll bring up the Options toolbar. By clicking the Share button, you can share your query with one or more teams or with one or more individuals. Simply select the teams or individuals with whom you'd like to share the query and click OK. If you're sharing to individuals, you'll need to provide the email address so that they receive a notification that you've shared a query with them. If you do not have any teams associated with your account, you can create a new team by going to Teams and Create New Team. When creating a new team, the first thing you'll need to provide is a name and click Save. You will now be able to invite individuals to join your teams. To do so, provide their email address to TeamSQL. They will receive an invitation, and if they accept the invitation, they will be added to your team. Once someone joins your team, if you share a query with your team, that person automatically gets access to your query as well. If you have existing teams, you can manage them by going to Teams, then Teams and Management. At this point, we've covered signing up for TeamSQL, logging in, creating a connection, connecting to your server, running a query, working with saved queries, sharing your queries, managing your teams, and sharing your work with your colleagues. For additional resources on using TeamSQL, please refer to the description for this video. Welcome to SQL Basics Part 1. In our last video, we covered at a high level what the SQL language is, what it's used for, and what relational databases are. In this video, we'll move from theory to practice and cover examples that will help you get up and running with SQL queries. The whole point of a database is to store large amounts of information in a way that you can easily find what you're looking for. To that end, we'll begin our course with basic SQL statements that you can use to bring back data from a single table. The first statement we'll cover is the select statement. We can easily return the whole table using the select star from users statement. So let's break this down because this looks a little cryptic at first glance. Select is the operation we want, and in SQL, the star means all. So we want to find all rows. Now we need to know where we're getting this data from, so we provide the table name. In this case, it's users. So what we're telling the computer is select all of the data from the users table. However, when the tables you return get big enough, trying to return everything can be problematic. By default, TeamSQL's menu limits you to 200 rows. However, you can also do this by specifying the columns we want returned. So let's say that I want to bring back the name and date of birth for my users. We can do that by specifying the names of the two columns in our SQL statement. Select name, comma, date of birth from users. Okay, so now we've reduced this table down to the essentials. But could I refine my query even further? What if I wanted names and birthdays for my female users? Well, I could do those things using what are called conditional operators. Conditional operators allow you to select specific rows from the dataset. They go in the where clause, so our SQL statement will be altered to say select name, date of birth from users where sex equals female, and we'll put female in quotes because it's a string value. So in this example, we use the equal logical operator. However, we can easily use others such as and, or, and not. Whichever ones are available to you is dependent on the data type of the column. So let's say that we want to return users who are born in the month of April or later and female. We can then alter our statement to say select name, date of birth from users where sex equals female and date of birth is later than April 1st, 1990. Well, what if we wanted to use or? This would give me users who are born in April 1990 or later, or female. The query would also return those who met both criteria. We can do this using select name, date of birth from users where sex equals female or date of birth is later than April 1st, 1990. Conversely, we can exclude results. Let's say we don't want females in our result set. We can therefore run select name, date of birth from users while sex is not female. Well, what if you didn't want to search for exact matches? There are conditional operators for that. Like allows you to specify a pattern. You can use two wildcards when using like. The percent sign represents 0 or more characters, while the underscore represents a single character. So let's say we want people whose names begin with C. We can find them using select name from users where name like quotes C percent sign end quote semicolon. If you're using MySQL, note that you can replace like with I like for a case-insensitive search. Another useful operator is between. Let's say you want people whose date of birth falls in the month of August 1993. You could then query select name from users where date of birth is between August 1st, 1993 and August 31st, 1993. In SQL, you're not limited to using just one operator. You can easily string together multiple operators to really fine-tune your query. So for example, select name from users where name like percent sign M and sex equals female, or date of birth between August 1st, 1993 and August 31st, 1993. Just as an aside, it doesn't matter the order in which you list the operators in the where clause. To keep things simple, just know that the SQL optimizer will review the query and determine the best means of returning the data you requested. So that's a high-level overview of how you can return data and use operators to narrow down your result set. But before we finish up, I'd like to take a brief moment to talk about the null value. I'm assuming you're all familiar with the basics of data types, such as strings, dates, and numbers, but null is a relatively unique concept that has to be handled a certain way when returning SQL. As a refresher, a field with a null value is a field with no value. This is distinct from an empty field. You generally see this in tables where a field is optional. You can insert a new record or update a record without providing a value for this field. When working with null values, you cannot test for them using the comparison operators that we've covered, such as equals, greater than, or less than. You'll have to use the is null or is not null operators instead. So, as an example, select name from users where country code is null. However, if you wanted to find the opposite, that is, the records where the country code field is not null, you'd use select name from users where country code is not null. With that said, that covers everything I wanted to show you in SQL Basics Part 1. Check out SQL Basics Part 2, where we'll move from working with one table to working with multiple tables. Welcome to SQL Basics Part 2. In our last video, we covered how to work with and return data from a single table. But the point of relational databases is to segregate data so that there aren't redundancies. This means that, for a given query, we might want to return information present in multiple tables. So how do we do that? Well, that's where joins come in. In a SQL query, a join clause tells the server that you want to combine rows from two or more tables based on a related column between the tables. So let's say I have two tables. One table stores information about our users and another table stores information about their favorite books. We see from our users table that each person has a unique ID. To help identify the rows of books in each table, we tag each one with the ID. That means that one user might have multiple rows, each of which corresponds to one of their favorite books. So remember, one aspect of the join is that we have related the two tables based on a common column. In this example, the related column is the user ID. So let's say we want to find the favorite books for John Doe. Where should we start? Well, we can begin by finding John himself using select name, ID from users where name equals John Doe. Great, so now let's join the users tables and the book table. So we have select star from users, inner join, books on books.userid equal users.userid, where name equals Doe, John. Here, let's pause to talk about our syntax. Your join clauses should come immediately after your from clause, and you need to provide the column information on which you join. So you would join on users.userid equals books.userid, because as we discussed earlier, the user ID is a unique column that helps us cross-reference tables. Notice how the join has created a full table where we have all of John's information associated with each title. However, just because this data is displayed multiple times doesn't mean that we have the data stored multiple times, and this is one of the reasons why SQL is so powerful. We can create different types of result set based on what we need, even if we don't have the data stored in more than one place. So let's set aside our example for a bit and talk about the types of join that you can see in SQL. There are 7 types of SQL joins, and each one returns a slightly different subset of your overall data from the two tables. In the above example, we used an inner join, which only returns rows where the identifying column matches in both tables. If it is one table and not the other, or vice versa, the query will not return the result. Next up, we have the right join or right outer join. Suppose we have two tables, A and B. The right join will return all results that are in table B or table A and B. On the flip side, we have the left join or left outer join. Using the same tables A and B, the left join will return all results that are in table A or table A and B. Finally, we have the full outer join or full join, where we return everything in the dataset. This is analogous to running select star against the table. With that said, that's all for SQL Basics Part 2. We built on the skills we talked about in Part 1 and began working with multiple database tables simultaneously. Tune into our next video to learn how to write complex queries against your database. In this video, we will cover the basics of writing complex queries. We'll talk about additional ways you can return data, especially using set operators, and we'll cover aggregate functions so that you can perform computations against column data. Previously, we talked about joins, which allow you to combine two datasets side by side. But what if you wanted to stack one dataset on top of another? Well, that's what union is for. It allows you to write separate select statements and have the results on statement A display in the same table as the results from statement B. So let's say you have two tables with data points on people. Maybe one is for users and one is for staff. You can therefore stack the two columns as follows. Select star from users, union, select star from staff. Note, however, that the union clause only appends distinct values. Duplicate rows are dropped before the final result set is returned to you. If you don't want this to happen, use union all instead of union. And remember, if there are no duplicates, the result set with both will be identical. In all likelihood, you'll most likely use union all more often. Now let's get into when you can use union statements. There are 2 strictly enforced rules. 1. The two tables must have the same number of columns. 2. The columns must have the same data types in the same order as the first table. Now, union isn't the only set operator. You might also find intersect and except useful. Intersect is used to return the results of 2 or more statements, but only those rows selected by both statements. So let's say we change our union statement to select star from users, intersect select star from staff. Then the result set will only include people who are listed in the users table and the staff table. But what happens if we change intersect to except? Select star from users, except select star from staff. Well, we combine the two statements and return the rows that are found in the first statement but aren't found using the second statement. Just note that the rules for using intersect and except are the same as those for union. Alright, so that covers our section on working with multiple tables. Now that you can work with multiple tables, let's move on to writing complex queries. So another thing that would be helpful when writing complex queries are subqueries. You'll sometimes hear subqueries called inner queries or nested queries, but regardless of which term you use, subqueries are helpful for performing multiple steps, so to speak, in one query. You can use subqueries in several different clauses of a SQL statement, but it's easiest to start with a from statement. Here's a trivial example. Select sub dot star from parentheses. Select star from books where title like a percent sign and parens sub where author last name equals Miller. Let's break this down. The inner query, and make no mistake, it is a full query in its own right and must run on its own, returns all books from the table where the title begins with A. This result set forms the underlying table against which the outer query runs, which is looking for authors with the last name Miller. Notice that we have sub written after our inner query. That's because inner queries have to have names, and the way we have it written is how you would alias the result set. So from here on out, we can call sub, and that refers to the result set from the inner query. In this trivial example, you didn't really need a subquery. You could have used additional conditional statements in the where clause. However, in more complex queries, subqueries might be the best, if not only, way you can return the information you're seeking. You can also use subqueries in the where clause. Suppose you know the user's name and you want a list of their favorite books, but you don't want to provide a hard-coded user ID. You can therefore write something like select titles from books where ID equals select user ID from users where name equals Joe, John. In this instance, we don't alias the subquery since the result set is treated as a specific value. Finally, let's talk a bit about aggregate functions. Aggregate functions are used to perform computations against the column of data you return. You're pretty much summarizing the results of a particular column of data. For example, let's say you have a column of numbers. The min function gives you the smallest value in the column, while max will give you the largest. You can add up all the values together in the column using sum, or get the average value using average. You can also get frequencies using count or count star. Count star or count all counts all rows, while count, with the column name provided, counts rows that aren't null. Okay, so that's it for our complex queries video. In this video, we talked about using set operators such as union, intersect, and intercept, as well as aggregate functions to perform computations against column data. Now that we've talked about how you can work with data that already exists in a database, let's talk about how you get data into database tables. We'll talk about the 4 basic functions: create, insert, update, and delete, and provide you with brief examples to get you started. So the first thing you'll need to do is create something that you can use to hold your data, which is the table. Let's say that you want to create your own staff table that contains the user ID, first name, and last name of the staff member. You'd write something like this: create table, if not exists, staff, parens, user ID, integer, not null, name, varchar 100, not null, primary key, user ID, and parens, semicolon. So this script does several things, so let's break it down into smaller pieces. Remember, this isn't even close to being all the features available that you can use when running a create table script. It's just a trivial example to get you started. So anyway, we have the first line, create table, if not exists, staff, which means that if there isn't already a table named staff, create a table called staff. Then we have to define the stuff in our table. We want 3 columns. We have to provide some basic information for the column, namely a name, the data type it's going to hold, such as varchar, which is short for a variable character field, or integer, as well as whether you can have null values in the field or not. Finally, we have our primary key definition. You can only have one, and you can think of it as a lock of sorts that makes sure that you have unique values. For example, you might have multiple people named John Smith. The value that distinguishes them is therefore the column set as primary key, which obviously has to be unique. Because we want this value to be consistent, you should try to use something that can scale up and is numeric, since that is more efficient space-wise. There are certainly more that you should consider, but for the purposes of these exercises, we'll leave it at that. Okay, so let's move on. Now that we have a table, how do we insert data into our table? Well, if you guessed using an insert statement, you'd be correct. So we can write insert into staff values, parens 1, 2, 3, 4, 5, comma, Smith, comma, John, close parens, semicolon. And notice that our string values are enclosed in quotes. Okay, so what if you wanted to insert more than one row of data? Well, separate out the data rows by commas. But one of the benefits of a database is the ability to easily find and update your data. So let's say that Jane gets married and needs her last name updated. We can do that by identifying her row and changing that value. Update staff, set last name equals Miller, where user ID equals 12346, semicolon. Okay, so what if you wanted to delete a user? Well, first, if you're going to be deleting stuff, we'd like to remind you to back up your work first. Okay, so here's how you go about wiping John Smith from a database. Delete from staff, where user ID equals 12345. Notice that we're finding the distinct rows using the user ID, which we know is unique. While we're talking about manipulating our data, let's cover how you can make table-level changes. We'll cover two functions in particular, alter and drop. Alter allows you to change the definitions of the table. So let's say that you want to change the name of the table from staff to internal staff. You can do so using the following statement. Alter table staff, rename to internal staff. You can also do something like add a new column. Alter table staff, add column, zip code int, default null, semicolon. Finally, let's say that you want to drop the table because you no longer need it. Be very, very careful because this removes the table completely. If you want to remove all of the rows and leave the table intact, use delete instead. So let's say that you really do need to drop the table. Here's how to do it. Drop table, staff, semicolon. That's it. Alright, so that wraps up our segment on the basics of creating tables, managing its data, and deleting or dropping them when they're no longer needed. In this video, we'll cover some special TeamSQL features that make it easier for you to work with SQL databases. We'll cover snippets, which allow you to do more while typing less, filtering your data grid, which allows you to view a selected portion of your result set, and table structure previews. We'll also cover data sharing and exporting. When working with databases, you'll often find that you need to share your data with others. In this video, we'll cover several different ways you can do so. First, let's cover snippets, which you can think of as built-in formula sheets that help prompt you when you're writing queries. They're super easy to use. Whenever you're typing in an execution window, IntelliSense will see if you're writing something for which there is a snippet, and if there is, it'll display a window of snippets you might be interested in. Once you've found one that you'd like to use, simply click on it or highlight it and press Tab to populate your window with that snippet. At this point, you have a base query that you can customize to complete whatever task it is you're doing. Second, let's cover ways of analyzing selected portions of data. After executing a query that returns a large result set, you can use TeamSQL to filter the returned data without running another query. This allows you to analyze your result set in depth without running any additional queries and putting additional strain on your server. To filter your results, you'll need to execute a query. There's a search bar and funnel icon located above each column. These allow you to filter on one or more columns. If you have search parameters set for multiple columns, TeamSQL will only display the rows that match all of your criteria. To filter your results, you're going to use the search bar, where you can type in the values you're looking for. As you type, you'll see a drop-down of the fields that match what you're looking for. The filter icon next to the search bar provides search settings you can use. Basically, they tell TeamSQL how to handle the search parameters you're providing. You can choose from things like is not equal to, contains, does not contain. There are many other options. So once you've provided a search parameter and TeamSQL presents you with a list of results that match what you're searching for, you can click on the result to display just that row. Now, what if you wanted to review the data available to you at a glance, or you want to quickly refresh your memory on tables you've previously looked at? Table Structure Preview allows you to get a preview of the structure of the table easily, and you can access this information in one of two ways. Method 1 is to simply click on the information icon to the right of the table name. Alternatively, you can hold down Shift and click on the name of the table itself. TeamSQL displays a pop-up that includes things like column information and indexes that you have on the table. You can use this icon to change the window to a pop-up, which is useful if you're using multiple monitors. If you want to make sure that you have the most up-to-date information, you can use the refresh button. Method 2 is to simply click on the caret to the left of the table name. This displays the structure information in the tree view that is below the name and is useful if you want just a glance at the table structure. Now that we've written and run queries and returned its data, let's talk about how to export data from your TeamSQL instance. This is useful if you want to move data around or if you want to load your TeamSQL data into another database. By clicking on the name of the database, I can see a list of tables that it has. We'll just go ahead and open up the actors table and work with that. I can do this by right-clicking on actors and selecting the Open Table option. At this point, we see our data in the bottom pane. By right-clicking anywhere in the data table, I can bring up a pop-up menu with the option to export data. If I hover over this, I can see that I can export data in JSON, CSV, or tab delimited format. So let's say I want my data in JSON format. I click on that option and TeamSQL prompts me to provide a name for the file as well as where I want the data to be exported. So let's name this file testdata.json and save the file to my desktop. Now let's see if the file has been exported to my desktop. Okay, great. We can see that my data file is now on my desktop and I can open it to see all of the data that was once in my actors table. Great. This is exactly what we wanted, so we're done. In addition to simply exporting data, TeamSQL allows you to share the results from executing a SQL query via a link. To do so, right-click anywhere on the data table that returns from your SQL query. Click Share Table as URL and provide the following details: a title for your table, a description, whether you want it encrypted with AES-256, a password if you chose to encrypt your data, and how long you want the link to be valid. Create your link and share it with your users. Your users will now be able to use the link to launch the data table. If you have chosen to encrypt your table, your users will need to provide the password that you have manually shared with them. Once they have done so, they will be able to see the data that you have provided. The time displayed in the top right corner indicates how long the link will be valid. If your users want to refer to the data past that time period, they can export the data as PDF or Excel. Alright, with that said, let's wrap things up. In this video, we covered snippets, which are like built-in formulas you can use as query builders. We have these for all sorts of things, from inserting one row of data to adding and dropping tables. Next, we have data grid filtering, which allows you to examine small portions of the result set you got after running your SQL query. We also have table structure previews, which you can use to jog your memory about tables you've looked at without having to execute your queries. Finally, we covered ways in which you can share data with your colleagues. Congratulations for making it this far. In this crash course on SQL, we've covered a lot of things. You've seen the basic commands you need to return data from your tables and learned how you can work with multiple tables. We've also talked about the basics of writing complex queries and using aggregate functions on numeric columns. Finally, we walked through several different options for sharing your data with your colleagues, since it's unlikely you'll be working with SQL in a void. We also covered TeamSQL features such as snippets, which are like built-in formulas that you can use as query builders, data grid filtering, which allow you to examine a selected portion of your result set, as well as table structure previews, which you can use to jog your memory about tables you've looked at without having to execute any additional queries. We also covered data sharing and exporting. When working with databases, you'll often find that you need to share your data with others. However, there's always more to learn, so refer to the accompanying course material on where you can go to deepen your knowledge of SQL.